Hello viewers, I'm Maitli. Today we are going to see 11 Cbse Max Limits and Derivatives exercise 13.2 question number 10. Let's see the question. Find the derivative of cos x from first principle. So we are going to find the derivative of cos x using first principle. We know that cos x is equal to minus sin x, but we need to do it in first principle. Let us write, let y is equal to cos x. Now first principle formula is f dash x or dy by dx, whatever it is equal to limit h tends to 0 f of x plus h minus f of x by h. You can't substitute h 0 immediately because that should not be denominator 0 unless and until if there is no h in the denominator you can substitute the limit value. Till then, don't substitute the limit value for this first principle. Now, we know that let us take this to be f of x so that it will be easy for you to understand. So, f of x is equal to cos x means f dash of x is equal to, that is I am starting my derivative here, limit h tends to 0. In the place of x, f of x means here we have f of x plus h. F of x plus h means in the place of x just substitute the value x plus h. So, x plus h here, same way in this x we will substitute x plus h. So, cos x plus h minus cos f of x, we know that it is cos x by h. Now, we have a formula here as cos a minus cos b. I am taking this total to be a. So, cos a minus cos b. So, cos a minus cos b formula is minus 2 sin a plus b by 2 into sin a minus b by 2. So, I am taking this full as cos a minus cos b. Substitute the value here. It becomes limit x tends to 0 minus 2 sin, instead of a we have x plus h, here plus x, b is plus x by 2, same way into sin a is x minus, x plus h minus b is minus x. Now this 2 get cancelled. We have 2x here, so by h. Limit h tends to 0. We have minus 2 sin x 2x plus h by 2 into sin h by 2 by h. Now we know a formula for sin, that is limit h tends to 0. In limit we know formula limit h tends to 0, x tends to 0, sin x by x is equal to 1. As I told before, the denominator we should not have a h in the denominator. To remove h, if we take this side, we have sin h by 2. The value of the theta and the denominator should be same. If it is same and limit x tends to 0, then we know that the value will be 1. So, to make it to this form, I want h by 2 in the denominator. So, here we have h by 2. The same way, if we have h by 2 in the denominator, then we can substitute the value this to be 1, substituting the limit. In that case, I am multiplying the denominator and the denominator with multiplying and dividing with 2. See, we have no rights to change the question. Let me write everything. 2x plus h by 2 into sin h by 2 by, the denominator you can put anywhere. It can be by or the by, it's in the multiply, so you can put anywhere. I am multiplying the denominator with 2 and dividing the denominator with 2, so that this 2 get cancelled. I have not changed the question. Now this 2 and this 2, it is in the numerator and the denominator, so we can cancel it. Now if I substitute the limit value here or here the limit value I will substitute in the numerator. Here the totally I am taking this as sin x by x. So the value for here it becomes 1. When in multiply we can separately substitute the limit value. Here it becomes minus sin 2x plus 0 by 2 into, here if I substitute it becomes 1. Now this becomes 2x by 2, 2 get cancelled. We have minus sin x. So the derivative of cos x is minus sin x. This is the using first principle. That's all with the sum. Thank you.